Hello, welcome to my channel. Welcome to Noble Tutorial. Welcome to this particular session, a session where I want to see an example on how to apply the equations related to projectile motion. Now, particularly we have a question here, the question that's going to take us through almost all the equations that are related to projectile motion. But before I go on with the question, please don't forget to like, subscribe, and share with every person that may need to have fun with this information that we have. Please always share with them such that we can learn together. We learn as we enjoy. We enjoy as we learn. Thank you. Now, we have a question on board. This question is about projectile motion. Remember, we saw the formulas, the equations related to projectile motion. Now I want to see a practical example on how we can apply some of those equations that we saw some time back. Now, look at a question like this. A particle is projected with a speed v at an angle theta above the horizontal. When you read that, summarize it. In your solution, I'm doing a solution here. Now, here we have the horizontal. We have a vertical motion. Now, if a particle is projected above the horizontal with speed v at an angle theta, look what it is. A particle is projected. That is the angle they are talking about, angle theta, with speed. Which speed is v meters per second. Now, they continue and say, if the particle passes through the point P, which is xy. Remember, as this particle is moving, as it is starting to decelerate, the point at which it starts decelerating becomes the point P they are talking about. It passes through the x and y axis. So just imagine people who go for high jump. If I was here, the moment I start from here and I jump to this side like this, what I've done a projectile. As I was in air, I was a projectile. So I moved from a particular point at an angle. When I was sloping, so I passed through a point, which point now they call P. Now, if this particle goes up to that point, so the point P is the point here. That is what they call point P. The point through which this particle passes to get to the destination. Now they are saying, write down expressions of x and y in terms of v, theta, and time t. Now, these people are playing with your minds. When they ask for expressions of x and y in terms of v, theta, and time, do you remember? We say we had horizontal velocity. Do you remember? Vertical velocity. Do you remember? Now we have horizontal distances and vertical, but that's what we want. Express it just in that form. Look at this. When you talk about velocities are horizontal. Assume this is point O. Let's assume this is point O. And let's assume, did they mention anywhere the point? Did they mention the points? No. Assuming this is point O and this is point M. Assuming those are the points. So horizontally, what's our velocity? Remember, horizontally, we move with uniform velocity. So horizontally, we say velocity now is v. It is moving with velocity v. It is v cos of theta. Cos of this angle. Remember, in the first, in one of the tutorials for projectiles, we resolved this, and you know why it is equivalent to that. So vertically, when you look at just vertical, remember this is y and this is x, please. So when you have y, that's what we are looking for now. Horizontal is x and vertical is what? Is y. We are expressing x and y in terms of v, theta, and t. So we shall have vertical as v sine theta. Remember, we are looking for the opposite to this angle. Opposite of hypotenuse. The hypotenuse becomes the v. The longest line of this right angle triangle. Hope it is clear. Now the distances. horizontal distance x. When you look at this horizontal, remember horizontally, we use the second equation of motion, which is s equals ut minus half at squared. I know you know that very well. When you come here, you put in horizontal, it is uniform velocity. With uniform velocity, acceleration is always 0. If it is 0, so it is v cos theta times time. Because acceleration is 0, so the other part that I have 80 squared dissolves to 0. Then vertical, that is y. Y replaces s because you're talking about vertical movement. Y is, it would have been ut, but remember, the u, they gave us their initial velocity as v. So it is v sine theta. This one just replaces, because we are using this, s equals ut plus a half 80 squared. This is what we are using. So when you put s, that is substituted with y, v represents u, v sine theta represents the vertical movement. So times time minus a half dt squared. Why minus? You remember what I said? Remember what we said previously? That as it is moving in opposition of gravity, its acceleration becomes negative g. So when you have this written here, you've done what they wanted. That is Roman 1. Roman 2, they are saying hence. We say hence in mathematics means from where I stopped. That's what hence means. If somebody says hence, all other words, show that y is this. You just need to smile. Look what it is. They are saying y, and y is here. That's the equation of trajectory. What you do, you substitute. Look at the first one. When you look at this, if this is maybe equation 1, and this is maybe equation 2, you have to say from equation 1, t is equivalent to x out of v cos of theta. When you look at the value of t, now substitute it into the second equation. Substitute for t. So we shall have y is equivalent to v sine theta times x out of v cos theta. This one that is this one sitting where we have a t minus dt. Now x out of v cos theta, but squared. Move on. It is y that is equivalent to this v will cancel with that v. So this one goes. So what remains here becomes sine divided by cos, and that one is a tan ratio. So we shall have x tan theta minus d x squared out of v squared cos squared theta. Check what they need. If this is what they need exactly, then you say, yeah, this one becomes done now. This one becomes a done deal. That's what they wanted. For Roman 2. Roman 3, show that the range on the horizontal through the point of projection is r equals v squared sine 2 theta out of g. Now look at this clearly well. When you look at this clearly well and look at this vertical motion, when we are talking about range, we talk about the distance from the first point to the last point of this projection. When I do this, from this first point to the last point, the range is that horizontal d. Listen, remember we have both vertical application. So what you need to get the time of flight. After getting the time of flight, multiply it with the horizontal distance. When you do that, everything will be done. So what you do here, you say from, when you look at this, clearly well, from equation 2, y is equivalent to v sine theta times t minus a half dt squared. Look at this clearly. When you look at this, at a point, look at this. At this point M, the vertical distance is 0. At this point M. So the y value shall be 0. And again at this point, time will not be the time taken to attain maximum height, but will be the time of flight. So the small t turns into capital T. So you have at point M, we shall have y equals 0 and t represented by a capital T. If that happens, do the substitutions. So we shall have 0 giving us v sine theta times t, now t becoming capital T, minus a half dt squared. Look at this. When you multiply through by the LCM, which is 2, you're going to get dt squared giving us twice v sine theta. When you look at that, so if that is the case, you are looking at v sine theta times t. This one goes the other side. So we shall have t alone. This one times t. Now this t will cancel, we don't know what that is. So t will be 2v sine theta out of t. This will be the time of flight that we need. If that is the time of flight, this person wants the range. What did he say? Range is the horizontal distance. Range is equivalent to the horizontal velocity multiplied by the time of flight. The horizontal velocity is v cos theta times the time of flight, which is twice of v sine of theta out of v. When you look at this, v times v becomes v squared. So we shall have v squared times 2 sine theta cos of theta, the whole of it is out of d. I'm taking you back a little to your trigonometry. Do you remember that from double angles, sine of 2 theta, from double angles, sine of 2 theta is equivalent to sine theta, cos of theta. Look at the other one. So we have, it is range that is equivalent to v squared sine 2 theta out of v. This is what this person wanted. And when you prove that, you stand and say, yes. You know, mathematical happiness comes when you prove something right. After having the range, look what part B. Part B says, a motor fires shells at different angles. A motor, it is firing shells at different angles of projection from point O. Let's assume this is our point O like it is. I'm using this as a diagram still. If the speed of projection is root of 50 degree, now the V now is given as root of 50 degree. Take a note as you are reading the question. And where D is the acceleration to gravity, and the shell is projected so as to pass through the point B. Now, this one they are taking from point B, but we are very well aware that as it was projected, they gave us P into X and Y, X and Y. So this is our X, and this is our Y. Find the possible angles of projection. Can you imagine? Everything is given. Go back and look at the first thing you proved. That is from, this is part B, from Y equals X tan theta, minus X squared G out of 2V squared cos squared theta. Yes, when you look at this, what you're given y as 20, x as 10, v as root of v, 50 degree. If this is the case, now make the substitutions. So y will be 20 is equivalent to x, which is 10 tan theta, minus x squared, which is 10 squared now, making it 100g out of 2. V is root of 50g cos squared theta. Now, but V is squared, sorry, V is squared. So this one will turn into 20 equals 10 tan theta minus 100g out of, this is 100. When you get this square, the square will go with this root. 2 times 50, you get 100g as well, cos squared theta. This one has been seen very well. When this one comes out with a root, 2 multiplies 50, 50 becomes 100 because it's multiplied by 2 to get g, then 100g. In this sense, practically this one will cancel with this. Practically, those ones will go. I'm going to rub off this. I have no option. So we say it is now 20, that is equivalent to 10 tan theta minus 1 out of cos squared. We all aware that is the same as sec squared, that combination. So it is sec squared theta. Since this is a tan, it is easier to turn a sec into tan than turning a tan into sec. Because when taking this together, you have roots which will be a bit complicated. So we shall have 20 is equal to 10 tan theta minus 1 plus tan squared theta. You are now having a quadratic equation in tan. What we do, open the bracket and rearrange. So we shall have 20 10 tan theta minus 1 minus tan squared theta. You can do 2 things here. You can either get all of this information, bring it to this side and rearrange, or bring this to this side and divide through by negative. So we shall have tan squared theta, if we go to this one, minus 10 tan theta, if this one also crosses. If negative one crosses, it becomes positive. So we shall have plus, is it plus? Yes, plus 21 is equal to 0. The other side has nothing now. The product now is 21. The sum is negative 10. 2 values whose sum gives us negative 10, whose product gives us 21. You remember we get those ones from the factors of the product, which is 1, 3, 7. This is 21, and possibly 21. When you have this pair can give you 21 when they are multiplied, but there's no chance they can give you negative 10. So what you do, you look at this pair. When you multiply them, you get 21. But when you add them, can you get negative 10? The answer is, if they are positive, it can't. What do? Change both of them to negative. When they are both negative, you have negative 3 plus negative 7, negative 10. When you multiply negatives, you get positive. So, or when you realize the factors you've got in them, so it is 10 tan squared theta minus 7 tan theta minus 3 tan theta plus 21 is equal to 0. Do the factorization, please. So we shall have what is common here becomes tan theta into tan theta minus 7 minus, here 3 is common because it divides 21. 3 into tan theta minus 7 is equal to 0. Have you seen this? That they are resembling? If they are resembling, then you smile. You know you're on the right track. So factorize out what is common. It is tan theta minus 7 into where there was this remaining tan theta minus where there was this remaining only 3. And this one is equal to 0. I'm rubbing off this. I don't want to rub off this because we've not done that part. When you look at this, it is either tan theta minus 7 giving us 0. So tan theta practically will be 7. Practically will be 7. And When you go here, we shall have all tan theta minus a3 is equal to 0. So tan theta is equal to practically 3 positive. Can I have a calculator? Get me a calculator, please. Get me a calculator. And do this one practically. Yes, get me a calculator. Get me a calculator. Thank you so much. Thank you. When you look at this, we are now getting the value of theta. Getting the arctan of 7. We get the value of theta here. Should look at the arctan of 3. The arctan of 7. As you're also finding out the answer, the arctan of 7 excuse me, give it back to him. Give it back to him. Can I have a better one? Arctan of 7, what have you gotten? Arctan of 7? 1.428. Arctan of 7? I need an angle. Is it here possible? Put it to degrees. Put your calculator to degrees and get me the arctan of 7. Change it to degrees from radians if it is in radians.
So 81.8.
It is 81.8. 8 two decimal places is 8.
81.87.
870 degrees. Then arctan of 3 with your calculators in degrees, yes? 71.57 degrees. So those are the possible values of theta. Hope this is what they wanted for that. Now, here comes the challenging part. According to what has been said by you particularly, did you see that? The difference between the corresponding time is taken to travel from O to B is 10 minus 2 root 5 out of root of E. So, when they said, did you see that the difference between the corresponding time is taken to travel from point O to B is this? Put your minds back. We are traveling. Go and look at the x, the horizontal distance here. We'll wrap up everything. According to our projectile diagram we have written, x was equivalent to cos of theta times t. When you look at that, this person wants us to get a difference in times that are corresponding. They want us to prove this time now the answer is given to us. So we are meant to find this answer, if really is true. If it is not, we shall tell them, it was had an error, so it's wrong. So when you have this, make it t the subject, since that's what they want. So t shall equal to x out of cos of theta. Now, have you ever thought of a relationship between a cos and a tan? When you look at a tan, can you imagine it having a relationship with the cos? The answer is yes. Because if sec has a relationship with the cos, yet sec relates with the tan, then automatically a tan relates with the cos. Go back and look at these two values. When you look at this, from t tan theta equals 7, do you realize that tan squared theta is 49? If this is true, then 1 plus sec squared theta shall be 49 squared. when one goes the other side, 1 plus tan squared equals, sorry, it is 1 plus sec squared, it is 1 plus from 1 plus tan squared theta that gives us sec squared theta. So when one goes the other side, tan squared theta practically is equivalent to sec squared theta minus 1. If that one is true, then what about, what does, tan squared is being given to us, which is 49. So this will be a 49. If it is a 49, this one crosses back to this. If it crosses, it becomes a plus. So we shall say plus 1 equals sec squared theta. You realize that sec theta is root of 50. If sec of theta is root of 50, yet every one of us here is aware that 1 over cos theta is always sec theta, but this one is root of 50. So we shall have 1 over cos of theta giving us root of 50. If this is true, what about what is cos now? So cos of theta shall be 1 out of root of 50. That is cos of theta. When you get to cos of theta, T1 shall be substitute for this. X was given. We had x as 10. Do you remember? We had x as 10. We had x as 10. So we shall have 10 divided by cos theta, which is 1 out of root of 50, which is x equals t equals cos of theta. So it is equaling to T1 equals to, so we forgot this. We forgot a v here. Because the x, the horizontal distance with v cos of theta times t. So we forgot a v. This is v cos of theta. So if it is t out of v, which v was given to us? I remember having v with us previously. V was v in the question. In the question, what was the value of v? Let me check here. The value of v was root of 50 g. So if it is root of 50 g, so we shall have root of 50 g times cos, which is 1 out of root of 50. If this is true, it implies T1 shall be 10 out of root of g. Why? Because when you multiply this practically, this will be under root 50 out of 50 g. So this one will cancel out. And we have 10 out of root of g as T1. Then when you've done this one to get a T1, get T2 using the other value of tan theta. So for tan theta equals 3, do the same trick. We shall have tan squared theta as 9. Then we shall have sec squared theta minus 1 giving us 9. So this one will cause and become positive. So we shall have sec squared theta giving us 10. Implying that sec theta will be root of 10. If sec of theta is root of 10, what about cos? You go back to that relationship. 1 out of cos theta is equivalent to root of 10. So cos of theta will be 1 over root 10 when you use that. If that one is very clear, now try getting T2. Don't mind mathematical proofs, you just follow a right proof. Well, so long as you have the right procedures and principles, just be consistent. So T from T equals x out of v cos theta. We shall practically have T2 as x was 10 divided by v, which is root 50 g, times cos of theta, which is 1 over root 10, 1 out of root 10. Practically, this one is going to be root 5g because this one will divide this. So you have t2 as 10 out of root 5g, and that is your t2. If this is your t2, now get the difference. The difference, if you get t1 minus t2 maybe, we shall have, what is t1? 10 out of root g, 10 out of root of g, minus 10 out of root of 5g. Get the LCM. The LCM here becomes root of 5g. If this is LCM, it divides this. Remember, this is root 5, root g. The root of g will cancel. So you have 10 root 5 minus, this cancels out with this to have minus 10. The moment you have this, look at it carefully and look at the answer you're looking for. If this one is practically written, we shall have root of 5g. Try rationalizing it. When you rationalize it, you're going to get a root 5g up and a root 5g down. So we shall have, this will be the same as 10 root 5 minus 10 root 5g out of root 5g times root of 5g. When you look at this multiplies inside now. So you will have when you look at this, root 5g, yes, has everything moved on well? Root 5g, yes. When it is out and multiplied through, shall have 10. When root 5 multiplies, this one multiplies this to have, this one multiplies this to have 5g. If this one multiplies this, we have 5g. When you look at this, you're going to get 10 root 5 times the other one. We shall have 10 times root of 25g. Because this one multiplies this. Then minus 10 root 5g. When the root 5g enters. The root of 25 is, the root of 25 is 5. So 5 moves out and multiplies this 10. So we shall have 50, now the root 5, the root of 5 which is 5, root of g, minus 10 root of 5g out of 5g now. This 5 divides both this and this. When you look at 5 clearly, if it divides, you'll have what are you proving? Look at what you're proving. When it divides, this one becomes into 5, you get 10 root of g, minus divides here 2 root 5 g out of g now. It is just g. Now the question is, it is g, we need the root of 5. Sorry, we need the root of g down. Look at this. Root of g is common here. I hope you can realize it. Root of g is very common. Because this is root 5 times root of g, which gives root 5g. So you will have 10 factors out root of g. Root of g into 10 minus 2 root 5 out of g. Now you see, the numerator is in our hands. You can even start taking some little water. Because you are now sure the answer is close to possible. When you have this, rationalize root of g. Rationalize root of g, you're going to have root of g times root of g out of root of g into 10 root of g times g, because there is this g now. 10 minus 2 root 5. When you multiply root of g times root of g, you get g. When you get g into 10 minus 2 root 5 out of g times root g, you get g root g. This one will cancel. If this one cancels, practical sum has 10 minus 2 root 5 divided by root of g. Then you pop back at the eyes and check on what they wanted. And when you realize this is the answer, you clap for yourself as you seated in somewhere trying such a question. So, as per now, the purpose was us saying how simple can we apply some of the equations related to projectile, and indeed we've done. Thank you so much for following this. Please don't forget to subscribe, like, and share with other people that may need this information. Thank you so much.